right, so let's get back to it. Arc length. Arc length is very similar to, we've been talking, excuse me, let me start that over. We've been talking about measures of arcs. All right, find the measure of each arc. All right, measure is going to be in degrees. Arc length, this is just, all right, I want that piece, okay? To find the length of the entire circle, I mean the distance around the entire circle, or the perimeter of a circle, what would I do? Well, to find the length of the entire circle, I would find the circumference. Okay, so find the length of the arc is just the circumference, but you only care about, so how do we find the circumference? We find it by 2 pi r. I only care about my piece of pizza. Okay, I only care about the crust on my piece of pizza. So to find the crust on my pizza, my piece, okay? Now, granted, I may eat a lot of pizza. I do like pizza. I like it. I like Roots Pizza. I like a lot of different types of pizza. So I may have a lot of crust, all right? But I only care about the crust on all of my pizza. Whether that's half or 3/4 of the pizza, that's between me and my crust, okay? That's between me and my pizza, all right? Don't you worry, all right, about it. So, what was I saying? So I only care about the, my piece. Well, this right here, by the way, this means the measure of arc HG. So if the measure of arc, remember that little m means measure, is 60 degrees, and there's 360 degrees in an actual circle, all right, I'm going to do the measure of my arc over 360 times the circumference of the whole thing. So I only care about my fraction of the circle, all right? My fraction, my crust. All right, so I'm going to take my fraction of a circle. How do you find your fraction of a circle? Well, you take the measure of its arc and divide it by 360. Why 360? Because there's 360 degrees in the actual circle. Why am I using the circumference? Because I care about the crust of the circle. Now, there will be a case in our next lesson where we care about the cheese. But right now, we're only concerned about our crust. So if I wanted to find the length of arc HG, I'm going to write that arc length. In a different course, a lot of teachers will use this. They will use a lowercase s. You'll see that to denote arc length. I'm just going to write the word out, arc length. A lowercase s might confuse you a little bit right now, so we're just going to say arc length. Okay, so to find the length of HG, so I'm going to go length of HG with the arc over the top. It's going to be 60 over 360 times 2 pi r, which is 8. Now, here's the deal, okay? We don't want to multiply pi in our answer because it'll make everything messy, all right? All I want to do is multiply my constants. I want to do 2 times 8 and multiply it by this. So I'm going to show you how to do that in the calculator. I'm going to pause for a minute. All right, so I can do this a couple different ways. I mean, I know that 2 times 8 is 16, right? So I can go like this, 2 times 8 times, I'm going to do this in parentheses. Okay. Now I have a fraction, and that's fine. That can happen. Okay, so I can hit math, enter, enter, and get my fraction. So I got 8 over 3. So I got 8 over 3, and I just want to slap the pi on it. And inches. Let's say I didn't know that. Let's say I couldn't do, I didn't have the math enter portion on my, I didn't have a TI calculator. Well, I can do it like this. I can do 16. I know that 60 over 360 is 1/6. Why? Well, the zeros cancel out, and I know that's 36 divided by 6 is just 6, okay? I can do 1/6 times 16 over 1, which is 16 over 6. I multiply straight across the top, divide both by 2 to get 8 over 3. Now, the future of these numbers hopefully will be a little bit nicer for you, so you don't have to have a fraction like that. Okay. Again, this wants me to find the length of JH. Well, I know that JKH is 60. Well, if this angle is 60, then the arc is 60. GK is 6. GK is the radius. So these are all 6, right? Okay, so to find the arc length, I do the measure of my arc. So a lot of people call it mark. Mark over 360 times 2 pi r. All right, I'm going to pause here. I'm going to have you fill that in, at least set it up and see how you do. All right, so here was my setup. Measure of my arc I found was 60 degrees over 360 times 2 times pi times r, which is 6. Okay, so if I type this into my calculator if I want to, I know that 2 times 6 is 12. I'm just going to write this all out for you. 2, whoops, that's a 1, 2 times 6. God bless America. Maybe 6 times. Okay, holy buckets. Let's have some fun. I could type it all out just like that. Wow. Enter, and I get 2. So my answer is 2 pi. Don't forget the pi. We're just slapping the pi on it. Inches. Okay. Now here's the deal. A lot of us, if we get a decimal, we'll slap the pi on it. All right, and that'll make it confusing. If you slap the pi on it, you get like 6.28 something. All right, leave the pi out of it. Make your life a lot easier. There are these theorems that are all congruent. Congruent central angles imply congruent arcs, which we talked about. All right, our central angles determine our arcs, and they also imply congruent chords. All right, so these are all connected. We're not going to harp on this too much, but I just wanted you to see it. I don't know what's going on. And that's it for today. I know this was a little bit longer than usual. I apologize for that. It's kind of a beefy section, but yeah, hopefully it was manageable. All right, I'll make sure that the assignment length isn't too long so that it won't take you too long for the day. All right, have a great rest of your day.